Alright, so I'm going to be going over Unit 5, Lesson 4, Tables, Equations, and Graphs of Functions. Again, I'll probably be coughing through this video. I'll try my best to keep it at a minimum, but I am currently out with COVID, so bear with me. We're going to go over a few notes before we start this lesson. So only equations with a power of 2 will curve. Okay, that'll make more sense in a minute when we look at some graphs, because we have to identify the correct equation that goes with that graph. Most of all the lines we've looked at so far have been straight linear lines. There's been no curve. When you get further into functions, which you'll get further into them in algebra, power of 2 is going to make the graph curve. So we'll see that in a minute. Then another note in an equation, so we're going to look at different ones. We've got to identify the independent, dependent. Your y is always going to be your y is always your dependent, because y depends on x. So y is always your dependent, which is your output. Okay, and then x is always your independent, or your input. So remember, graphing equations, they're going to be written as y equals mx plus b form. Okay, so that's how they're going to be written. So that first variable is always going to be your dependent. That variable that's in the actual equation after the equal sign is going to be your independent. So if we look at this one over here, that first variable, even though it's not y, it's d, it's still your dependent, because it's in place of your y in the y equals mx plus b. So this is your dependent. So that's your output. And then, so this variable has to be your independent, which is your input. Okay, because it's where x would be if we were looking at it y equals mx plus b form. Okay, so first variable is your dependent, middle variable is your independent. Yeah. Alright, remember that y is a function of x because y depends on x. And then, to identify a function, remember you check your x values or you do a vertical line test. So checking your x values, you make sure none of them are repeating. If they are repeating, it's not a function. If it doesn't repeat, it is. Vertical line test, remember if it goes through the line more than once. Yeah, if it touches more than once, then it's not going to be a function. Sorry, I keep getting emails that keep popping up at the top of the screen. Alright, so let's look at this. This is on page 125. The graphs of 3 functions are shown. So if you look at A, that's that curve I'm talking about. It's a very slight curve, but it still curves. And then B and C, there are graphs like we've looked at before. Number 1 says match one of these equations to each of these graphs. Alright, so we got 3 different situations we're going to read, and we're going to match it to these graphs. So A says D equals 60t, where D is the distance in miles that you would travel in t hours if you drove at 60 miles per hour. Alright, so that's got a power of 2 in it. It's got to go, it's in one of those straight line graphs. Everything in this equation is positive, so it's going to be a graph that's going up, so it's going to have to be B. Because B's going straight up at a constant rate. This one's going down, but you would have to have a negative. First equation doesn't have a power of 2, so it wouldn't curve. So this is going to be B, because it's going up at a constant rate. Okay. B says Q equals 50 minus 0.4D. where Q is the number of quarters and D is the number of dimes in a pile of coins worth $12.50. Alright, so what we notice is this subtraction sign here. If this was written in y equals mx plus b form, it would be written as y or Q equals negative 0.4D plus 50 if we were to rearrange it so that it was in y equals mx plus b form. That means there's a negative slope, okay, because that number that your variable is attached to in the equation is your slope. So that's going to be the negative here. So that's going to be your straight line that's going down because it doesn't have a power of 2, so it wouldn't curve, but it's got that negative, so it's going to go down. So that's going to match with graph C. So C has a negative slope. Alright, and then that means our last situation, C down here, A equals pi times r squared, where A is the area in square centimeters of a circle with radius Dolly. Sorry, that was my dog. Where A is in the area in square centimeters of a circle with radius r centimeters. That one's got that power of 2 that I told you about. So that's going to be your one that curves. Okay? So that's going to match with A. Has a power of 2. Alright. So now I've got each one of these matched. So number 2 says label each axis with the independent and dependent variables and the quantities they represent. Alright, so let me erase these 2 lines. So remember on this page, I showed you that in these equations, your first variable is your dependent, your second variable is your independent. Okay, so if we look at A, or situation A, our first variable listed is D. So that's going to be our dependent. Your dependent goes on the y-axis. So I'm making note of that up here. Dependent, y, independent is your x. Okay, so since that D is our dependent because it's the first variable, you're going to put distance on the y-axis of that graph. Which means t is the x value because it's the independent variable. So that's going to be hours. So we got hours on the x-axis. So you just look at your first variable, that's your dependent, that's your y. Your second variable is your x, which is your independent variable. So let's look at the next one. We've got Q equals 50 minus 0.4D. Q is in that y space. Q stands for quarters, so we're going to go to graph C. And on our dependent, which is our y, we're going to put quarters. Which means D, that stands for dimes, is going to go on the x-axis for the independent variable because it's in that x value or x spot in the equation. Alright, and then we have the last one. A equals pi times r squared. A is in the dependent variable spot, so that's going to be your y, so that means area is going to go on the y-axis. And then r is in our x spot, and that's for radius, so under the x you're going to have radius r. So now each one of these graphs has its x and y axis labeled. Alright, so now I forgot to put that question on there. Give me just a second. I gotta go back in and add a question. Let me pause this video. Alright, so this question, number 3, underneath it, goes with this. It says, for each function, what is the output when the input is 1? What does this tell you about the situation? Label the point on the graph. I'm going to go ahead and tell you we are going to skip number 4. So I'm going to mark that one out so I don't even have it. It's just going to be a scribble in my space. Alright, so we're going to take each one of these equations and we are going to plug 1 into them. Figure out what the coordinate would be, basically, what the x and y values be. So we're starting with that d equals 60t equation. Goodness, I don't know what I wrote there. D equals 60t. So this is our output spot that D is. So our input is t. So we're going to replace t with 1 because we're trying to find what the output when the input is 1. So it's going to become D equals 60 times 1, which means D is going to equal 60. Okay? So what that means, since 1 replaced t, that's 1 hour. And D is 60, so that's going to be 60 miles because we're looking at miles for distance. And your coordinate, you're just going to bring those numbers and write it like this. So all we did was plug 1 into the equation, which replaces your x value. That's why it's first, because that's your x. We got D equals 60. D is your y, so that's why 60 is in that spot. So that's telling us that since we're talking about distance in miles and traveling in hours, that's telling us that it's 1 hour, 60 miles when we plug 1 in. So we're going to go back and label that coordinate on our graph. So that situation matches with graph B. So you're just going to go above your 1 on your x-axis. This is your x. This is your y. So you're going to go to 1 and you're going to go up to the line where it's at. And you're going to put that point. Alright, let's do the next one. We have B, which is Q equals 50 minus 0.4 D. Alright, since this is our y value, we're going to leave it alone because that's our output. So we're plugging 1 in for the D because that's where your input would go, because that's your x value, or that's your independent variable, that's your input. So this is going to become Q equals 50 minus 0.4 times 1, which becomes Q equals 50 minus 0.4, which means Q is going to equal 49.6. So that's our y value. This is our x value, that's your y value. So what that means is here's our coordinate, 1, because that's our input, so it's going to be your x. And then we have our new output, which is our y value, so 1 and 49.6. Since 1 represents D, that's 1 dime. 49.6 is represented by Q, so that's 49.6 quarters. So that means if we plug 1 into that equation, we've got 1 dime and we've got 49.6 quarters. So we're going to go back and graph that. So we're graphing this coordinate 1, 49.6. That's going to go on graph C. So we're going to be really close to this line. We're just going to be almost touching the edge of it. So that's 1 and 49.6. Because they go up by 20s and they go up by 10. So it makes it a little bit harder to graph the x. So we're just going to stay as close as we can, but not be directly on that line. Alright, one more. We got to do A equals pi times r squared. Alright, so this is your output, this is your input. Our input's 1, so r is going to be replaced with 1. So A equals pi times 1 squared. So A is going to equal 3.14. And we are rounding, okay, because we end up getting pi back to us, okay? 3.141592 something other. That number never stops, so we're going to round. So we're going to say A equals 3.14. That's our output, so it's going to be the second thing in our coordinate. And our input was 1, so it's your x, it's your first. So that means for radius of 1, talking about circles, circle has an area goodness of 3.14. And we're going to go graph this coordinate. So you're going to go to your 1 on that first graph and just plot a point, and that's 1 and 3.14. Alright, so that's all for page 125 because we are skipping that fourth question. The next part of this lesson we're looking at is going to be a whole lot easier.